All right. Miss Williams, are we still there?
Yes, sir.
Okay, Miss Williams. So you have had enough time to reflect on your answer. Do you now want to share your answer with us?
Sir, I think, not sure though, it's 2440.
2440. You're holding that position?
Yes, sir.
Okay. All right. Let me find out from somebody else what they think. Miss Shay?
Yes, sir.
What would your answer be corrected to 3 significant figures? If you correct the sum to 3 significant figures.
Sir, I am still working it out because I'm not sure if
Do you have an answer for us?
no, sir. Not a sir, I'm not confident with my answer.
All right. Miss Cabrera, 3 significant figures.
Sir, 244.
And that's your answer, Miss Cabrera?
Yes, sir.
All right. Trying to see who else I can call on now. All right. Let me ask. Mr. Paisley, 3 significant figures.
24400.
Is there anybody who is in agreement with Mr. Paisley?
That one is the three significant figure answer, sir.
Yeah.
Yes, sir. 2440.
Okay, Miss Cummings, you're in agreement. All right. Now I want Miss Cummings to explain why that is the answer.
So because it is a whole number, so you put back this 0 as placeholders.
So in other words, after you count the 3 significant figures that you're dealing with, 1, 2, 3, that means you're rounding off to that one. And then you round up and you add 1 to this 3, you get 2, 4, 4. Now these
Yes, sir.
These digits, we can't just drop them off. You realize that, Miss Williams, we can't just drop those off. The only time we drop off numbers is when they come after the decimal point. But these, we can't just drop them off because this number is a whole number. If you read what this number is, it is actually 24,392. To drop,
Okay, sir.
to drop off 2 digits off it and get 244, that would be grossly incorrect. That would be like getting your pay and then dropping off 2 digits off it. You wouldn't be happy at all about that. So you would have to replace these with zeros for it to be meaningful. So instead of 244, you would have what? 24,400. Is that clear to you, Michelle?
Yes, sir.
Okay. Is that clear to everybody? Let me see the hands of those who are okay and clear about this. Okay. All right, good guys. All right. So I see where everybody is following so far. Now, so the 4 significant figures, we would just count the first 4 digits, see whether or not we can round up. If not, we replace that digit that follow with a 0. And for the other one, count the first 3 digits. If we can round up, we round up, and then we replace what comes after with zeros. Now, here we have this number here. Now, Miss, call on some bright sparks. It's green. 2 significant figures for question 2. Are you there, Miss Green?
Yes, sir.
Yeah, round this off to 2 significant figures for me, please.
Sir. 2 yes, sir.
I'm listening. 2 significant figures.
Sir, I'm not sure.
All right, Miss Green is not sure. Let me call on somebody else. Miss Cabrera. 2 significant figures.
Sir, I'll say 0.0850.
All right. Remember your answer, Miss Cabrera. All right, let me find out now from Mr. Reed. 2 significant figures.
0.09.
Okay. All right. Remember your answers, guys. All right. Let me ask Miss Clark.
Sir, 0.09.
All right. Hold on to your answers, please. Miss Waysome. Ms. Cabrera, you want to say something?
Sir, I would like to change mine. It's 0.0860.
Sure.
All right. Mr. Shamar, you're saying something?
I have 2 answers actually. Because I was very sure. So I have 0.086 and 0.09. No, actually it should be 0.086 as well. So on and so.
All right. Doubtful Campbell. All right. Ms. Waysome, we're waiting on you.
Sir, you said to 2 significant figure,
Certainly, my dear.
rounded off.
Yes.
Sir, 0.09. Yes, sir, would have been the 8 and the 5. And you see where the 5 with the 5 is, you know, with the 5 thing you can actually add 1, sir.
So your answer is
0.09.
0.09.
Yes, sir.
All right. I want to hear some other answer. So we have 0.9. Any other answer? Somebody give me another answer now, different from this one. I think Miss Cabrera, you had what? 0.08
6, then 0.
0, right. Anybody else have another answer? Mr. Campbell, what's your answer again?
0.086.
0.086. Anybody else with another answer? Michelle, do you have an answer?
Sir, I have 0.087.
0.087. All right. Okay. Miss Clark, do you have an answer?
Yes, sir. 0.09.
0.09. You remember I said that sometime you're going to confuse the two of them. Now, for the persons who gave this answer, the 0.09, what you're really doing, you're rounding off decimal places. You're following, students? Remember now, for significant figures, you're starting to count your significant figure from what? The first non-zero digit from the left. What is the first non-zero digit in this from the left? Go ahead, Ms. Wilson.
But sir, you said rounded off, to the nearest significant figure, sir. So what I did was to just ignore this 0.0 and then focus on the 85.
The questions are corrected to
Yes,
it's right there on the slide, miss. So if you're correcting to two significant figures, it means that you have to count your first two significant figure, then you round off to that point. Now, the first two significant figure would be what? Miss Wilson?
85, sir.
So 8 and 5, but now we're rounding off to the 5. So we examine.
Mistake, sir.
So this number going to become what?
6. The 5 going to turn to 6.
Point
So it'll be
8. Sorry, I missed out a 0. 0.086.
6.
But down here, so now we see I have a 60, and we see we have a 0.086. Now, what is happening here now? Which of these is correct? This
Third have been the 0.086. Because you
this
said we only put back the 0 to whole place values if it is a whole number.
right. So this one, after we count the first two significant figure, if you add a 0 to this, what would you be doing here? All right, all right, all right. Let me ask you a question. Correct this to 3 significant figures and tell me what you get.
So would it be 0.0?
858.
Right. Now, this 0 that is being added here doesn't make any sense at all. Because the fact that we are working with 2 significant figures, the first 2 significant figures that are important, anything that comes after, and once it follows, the numbers follow the decimal point, this digit going to drop off. Remember, we don't put 0 here unless we are working with whole numbers. So to add a 0 here and keep it is not necessary. And if you put it there, it still will give you a wrong answer. All right, because this would give you, by putting a 0 here, you are saying that this 0 is significant. So only if you are really considering that these 3 digits are significant, that's the only reason why you would add a 0 there. All right, is that clear to everybody? So the answer then should be 0.086. So that is the correct one. All right, is everybody clear with that? Let me see the hands of those who are clear on that. All right, so the 2 significant figures, that is what we would have. All right, now look at this one. Who want to correct this now to 5 significant figures? Mr. Campbell, you want to do that? 5 significant figures?
You try, sir. That's all right. Yeah. I got or kind of quick one. I had a 425.8.
All right, so that's Mr. Campbell answer. Miss Shay, what would be your answer?
So for the 5 decimal, okay.
Decimal,
So for the, not decimal, for, for the 5 significant figures, sir.
yeah.
Sir, I am not sure.
All right, tell me what you have. Let me write down Mr. Shamar. Yours is what? 425.8.
5.8.
Ms. Shay, do you have an answer?
Not as yet, sir.
All right. I mean, Miss Green ready to give us an answer. Miss Green, what is your answer?
Sir, I'm not sure. Let me just try to say. Is it 425.80, sir?
425.80. All right. Miss Cummings, what is your answer?
So I agree with Miss Green.
I agree with Miss Green. Miss Waysome, what's your answer?
Likewise, sir. I'm agreeing with Miss Green.
All right. Miss Williams, who are you agreeing with?
425.80.
Okay. Ms. Cavero, who are you agreeing with?
Sir, second answer, sir.
Ms. Cavero?
Sir, I was saying that I agree with the second answer.
Okay. Let me see
Sir,
that those who agree with the first one, this one, let me see how the hands agree with the first one. Mr. Shamar, it seems like you left by yourself. All right, so Mr. Shamar, the answer is actually the second one. And can you see why though?
I guess they just left off 4 and just kept the 0.
Yeah, because if you leave off this 0, you wouldn't have 5 significant figures. Instead, you would have 1.
Instead of 4, oh, I got you.
You would have 4, right?
Yes, sir.
All right. Now, and for those who are not sure, I hope you see that. All right, now correcting to 3 significant figures. Ms. Williams, 3 significant.
Said Miss Williams, sir.
Yes.
Sir, I think it would be 425.8.
Let me write that down. 425.8. Right. Miss Cummings, what is your answer?
426.
426. Anybody else?
Yes, sir. 426.
Yes,
426. All right, so 2 answers here, 425.8, 426. Let's see the hands of those who are in favor for 426. All right, let me see the hands who said 4258. All right, so Williams, you are by yourself too. Now, the question though, why is your answer not correct, Miss Williams? How many, go ahead.
It's 3 significant figures, sir. So it would not be correct because
You have 4.
yes, sir.
You have 4. That's why it wouldn't be correct. So if it is 3, that means you have 3 and then round off. 1, 2, 3. I mean the number that follows, greater than 5, add 1 to this 5, so it becomes 426. It's a whole number, so you don't need to put back the point. Is that clear? Guys, raise your hands. Let's see who's okay with this. All right, there's an error in this answer. It's supposed to be 426. It's a typo. All right. So here we should have 426. All right. Any question? All right, no question. Let us move on. Now, we have what we refer to as standard form. So I'm just going to touch on this. Hopefully we can finish up on this topic. Okay. All right, Mr. Authors, yeah, we see your answer, 426. All right, now we have what we call standard form. Now, can anybody give me their understanding? If you have heard the word before, what you know about it? What do you know about standard form? Miss Ashanti, Miss Cummings, what do you know about standard form?
Sir, I don't quite know how to explain it, but I think I have an example.
All right, so let me ask Miss Clark, what do you know about standard form, Miss Clark?
So I'm not sure how to explain it either, but I think I have an example also.
All right, so everybody has examples. Nobody knows why it is standard form. Let me still find out from others. Mr. Jano, what do you understand about standard form?
Nothing, sir. First time hearing it.
First time I'm hearing that word.
Yes, sir.
Now, the word standard form is a way of writing numbers that have large amount of digits, or it has so many figures that you might find it a little cumbersome to write those numbers, to write them out on paper. Now, for instance, like scientists generally calculate things that might seem ridiculous.
I like what it is. It tastes good to you?
Scientists may, Miss Wilson, we don't want to hear how your food tastes. Scientists may want to calculate values that may just be so ridiculously large or ridiculously small that you have so many digits. Like, think about if you are trying to calculate the distance of probably the closest galaxy to us, then that distance is not normal. So we will have a lot of digits. Now to write those digits out on a page may take up a large space to write them out. And so in order to write these very large digits or very small digits, we come up with this method of writing them in a shortened form, which we call standard form. So standard form is a concise way, or it's a shortened way of writing very large digits or very small digits that are too cumbersome to be written on a paper. All right, so, and most of the time scientists have to work with these very large numbers, all right, because of what they're measuring. For instance, if we talk about the speed of light, anybody know what the speed of light is in terms of the actual value? Let me see if we have any scientists in the house. What's the speed of light?
200 something thousand. No.
So anybody knows? Go ahead, Mr. Javon. I mean, Sautas. You type it in the chat. Let me see.
But the speed of light is more than Mach 30.
No,
Sir,
I don't think that's what he wants to say.
sir, mind if I answer?
All right, go ahead, Mr. Campbell.
It's in the hundreds of millions, 200 and something million.
200 and something million. All right, if we round it off, it is
Basically 300.
300. Can somebody call this number for me?
3
300
billion,
million.
sir.
300 million meters per second. That's the speed of light. All right. Now, this is a pretty small number compared to some, but we may want not to write out this long number every time we're writing it out. So we would love to have a short way of writing it. Now, the shortened way of writing this is called standard form. Now, the Americans call it by a different name. Instead of standard form, they call it scientific notation. So whether you call it standard form or scientific notation, you're referring to the same thing, right? Even calculators will have a shortened form of writing large digits on them. And so they are referred to as scientific notation. So you can actually put your calculator in that mode to write these very large number in a shortened form. So there is a general form to standard form. So let us look at what the general form is. So, all right, standard form is a concise way to represent very large and very small numbers like these numbers. Now, a number in standard form is usually expressed in this form, a times 10 to the n. Now, even though it is written as a times 10 to the n, not all textbook has the first symbol as a and the last symbol as n. But what we know, a is a number and n is another number, but n would be integers. Anybody know what integers are? I shouldn't even be asking that question. Remind us of what integers are, students.
Sir, integers have to do with positive and negative numbers.
Positive or negative number. That means this value of n can be either positive or a negative number. Now, if we are to write such large numbers in standard form, what it means then, we will have to have a value a. And so from each of these numbers, we have to determine what a would be. And we also have to raise 10 to some power, which is to some power n. So we need to know what n. So before we can write any of these numbers in standard form, from them, we have to determine what value a would represent, and then what value n would represent. And so we're going to look at how to get a and how to get n when we're writing numbers in standard form. Because once we determine what a should be and what n should be, all we're going to do is to replace the a with that number and replace the n with the integer, and then the number would be in standard form. Is that clear to everyone? So let me go ahead now and explain. Now, if we are writing this number in standard form, how would we determine a from this number? I know some person have some ideas of how to write this already, so let me hear from Miss Clark. How can we determine what a is for that number? We want to put this in standard form, and standard form will look like this. This is general pattern for standard form. You have to have a number here, and you have to have a number here. All right, let me define what a, the value of a should be. A should be a number from 1 to 9. It cannot be more than, it cannot be 10. So you want a number a, which is a number from 1 to 9. And then you want a number n that tells you the power of 10 that you multiply by a to get this number. So can anybody start us off and try to determine how we're going to find what A is?
Sir, it's the first number.
A is the first number. All right, Miss. So you said what you're saying, A is equal to 6?
A is equal to 678. Yeah, 607. 678.
A is 600 and what you say A is 600 and
Just as A is 678 for now.
A equal to 6, 7, 8. Anybody agree with Miss Cabrera? Mr. Paisley? Mr. Paisley, you're in agreement? Anybody else agree with Miss Cabrera? Mr. Authors. Anybody else agree with Miss Cabrera? All right, Mr. Giovanni Reed, Miss Shea. Who else? Mr. Campbell. People are slowly agreeing. Ms. Waysam, are you in agreement with Miss Cabrera? That A would be that number?
So you said
Sir,
that
I am
A
not
could
sure to be
be a
honest,
number.
so
Okay, Miss Cummins, are you in agreement?
So I'm not quite sure because you said A could be a number from 1 to 9, so I don't think A would be that long. I'm not sure.
Exactly so. A is a number from 1 to 9. Now, these numbers are significant in deriving A, but A cannot be 678 for the same reason that you're giving now, Miss Cummings. Because I said to you that A has to be a number from 1 to 9. Now, if we are to consider a number from 1 to 9, and we're trying to make it from these three numbers, what would we get that number to be? Go ahead, Miss.
0.78, sir.
So